Good morning. How are you all? Hope you're all fine. Okay, so yesterday we started with number 9. As we mentioned in this question, we had 3 important ideas. Exactly 2 of them had the same area. I underlined these 3 ideas. 2 of them are isosceles and 2 are right angle triangles. And please, I'm sorry. Okay, please double line the exactly. So we will work, all our work will be on this word. So first of all, I'm going to repeat the question. Ali drew 3 triangles on a grid. Exactly 2 of them have the same area. Exactly 2 of them are isosceles and exactly 2 are right angled triangles. 2 of the triangles are shown above, which could be the third one. So we have 2 triangles and we need to choose the third triangle. Of course, we have these 3 properties that must apply on the 3 triangles. So these 2 choices and one of them. First of all, we're going to start with exactly 2 of them have the same area. So of course, I'm going to calculate the areas for everything, but now let us start only with these triangles. So let me name them 1 and 2. The area of triangle 1, you all must know the rule. Never forget it. Okay? The area is this side, because we need the height, multiplied by the base over 2. So let's count the units. 1, 2, 3, 4, 5, and 1, 2, 3, 4. So 5 times 4 over 2, which is 20 over 2. Let me call it A1. So A1 is equal, the area of triangle 1 is equal to 10 units squared. Of course, it doesn't matter now the unit, how much it is, because we must solve it and we have 1 unit for everything, okay? Common unit. So now the same for triangle 2. We're going to count 1, 2, 3, 4, and 1, 2, 3, 4. So 4 times 4 over 2, directly it's equal to 8. You know, 4 times 4 is equal to 16 over 2 equals to 8. Now, I have exactly 2 of them have the same area, so the third triangle must have the same area of either this triangle or this triangle. So the area of 3 is equal to 10 or 8. Now, we are not going to calculate 5 areas so to get the final answer. So let's skip it now. Now, exactly 2 of them are isosceles. So of course, we're going to have at least one of these 2 triangles to be isosceles. Let's check. We have this side to be equal to 5. This side is equal to 4. So this one is not isosceles. This one is 4 and 4. So of course, triangle 2 is isosceles. So till now I know that this triangle is isosceles. The third triangle must be isosceles because exactly 2 triangles are isosceles. So we have one here and we're going to choose the isosceles triangle from this figure. So first of all, this one looks weird. 1, 2, 3, 1, 2, 3, 4. So it's not isosceles. I'm going to take it off. This one looks isosceles, so let's skip it. And this one looks isosceles. This one, no. Obviously, maybe it is. So let's skip it now. exactly two are right angle triangles. So, of course, you know the right angle triangles. I have this to be a right angle triangle, and this one is a right angle, plus it's isosceles, so right isosceles, but this condition applies for these two triangles. So, of course, the third one should never be right triangle. Triangle, so I'm going to search for right angle and choice E also, so this is the reason why we removed that. Okay, now let's look for the area. So we skipped one, so it's easy now. We made less effort for calculating it. So the area must be equal to 10 or 8. So for example, let me choose C. Look, C and D looks perfectly isosceles, so I'm going to try them. If the area is equal to 10 or 8, so we're fine. Now, let's look at this one. First of all, the base multiplied with the height over 2. So let's count 1, 2, 3, 4. The base is equal to 4. The height is equal 1, 2, 3, 4, 5, 6. So 4 times 6 over 2. Directly the area of C, triangle C of choice C, is equal to 12, which is not 10 or 8. So of course we're going to remove it. I'm going to try this one. 1, 2, 3, 4. The same process. So 4, the base is equal to 4 unit, and the height is equal to 1, 2, 3, 4. So 4 times 4 over 2, which is 8. So the area of D is equal to 8 units, like triangle 2, the same area. Okay, so of course we're going to double check the conditions. Two of them have the same area, so I have triangle 2 and triangle D, which is triangle 3. Two of them are isosceles. This one is isosceles. We double checked. This one should be isosceles, as you can see by using Pythagoras. You can see it here and here. So this side is equal to square root of this multiply this one squared plus this one squared. So 1, 2, 1, 2, 3, 4, and the same applies for this one, which is 1, 2, 1, 2, 3, 4. So yes, I double checked, it's isosceles triangle. Now exactly two are right angles, so I have the first triangle to have a right angle and the second one the same. So this one must never have a right angle, sorry. So yes, we are fine, and I'm going to circle it directly. Okay, so this process is we are testing only the results to get the final answer. Okay, let's move on because this one is easy, so I'm not going to waste time on it. This one, the little kangaroo has chosen a special number. She gets the same result when she subtracts 1 over 10 from her number as she does when she multiplies it by 1 over 10. What is her number? Of course, we can do it on each one alone. I can directly take off some results. So 1 over 100 is smaller than 1 over 10. So if I subtract 1 over 10 from 1 over 100, I'm going to have a negative result, which is not fine. 1 over 11, the same process. So let's skip it now because I think trying a lot wastes time. So let's do it in the math way. Okay, first of all, I have a number. I'm going to denote it by x. X is equal to one of them. If I subtract it from x 1 over 10, the result is equal 2x multiplied by 1 over 10. Okay, so we translated the following given to a linear equation because it's easy to solve. Now, let's change the color and simply we're going to solve this linear equation. So x minus 1 over 10 is equal to x over 10. Okay, usually I have in the denominator 10 and 10, so I'm going directly to multiply both sides with 10. And if I did the thing, I'm going to be left with 10x minus 1 times 10 is 10 over 10, so it's 1. Minus 1 equal to x over 10 multiplied by 10, so I'm going to simplify 10 with 10, so I'm left only with x. Now simply take off the x from both sides. Here I'm going to deal with 10 minus 1, which is 9x. If you are confused, always remember I have 10 bananas, for example. I took one banana from them. How many bananas do I have? I have 9 bananas left. Okay, so 9x minus 1 the same is equal to x minus x, 0. Now simply add 1, get rid of this negative 1. So I'm going to have 9x equals to 1 and simply divide by 9 on both sides to get x equal to 1 over 9. Now we're going up. Simply we're going to choose the right answer. Okay, if you don't want to do all of this work, I think it's simple work, but if you don't want to work with x or solve equations, there's algorithm here. You can look 1 over 100 minus 1 over 10. We can test each choice. Of course, it's a negative number. We're not going to get by multiplying two positive numbers the same answer. Of course, I'm going to remove it. 1 over 11 is smaller than 1 over 10, so directly we can remove it. 1 over 10 minus 1 over 10 is equal to 0, but two positive numbers multiplied with each other will never get, we will never get 0, so I'm going to remove it, and then you can try 11 over 100 and 1 over 9. So if you tried these two, of course, E will be the right answer. 11 over 100 minus 1 over 10 is equal to 1 over 100. But if we multiply 11 over 100 by 1 over 10, we will get 11 over 1000, which is not equal. Okay, that's all on this exercise. It's an easy one also. Okay, now we are going to start with the hard exercises. I want someone to help me, please, with this exercise.
Yes, sir.
Yes, Mishari. Can you please help me?
I'll try to.
Okay, please. I
Dad
have.
has 10
Yes, please.
sparkles of the same size. He lit one first when he only a tenth of it remained. He lit the second one when only a tenth of that remained. He lit the third one, and so on. Sparkles burn at the same speed along their entire length. One sparkle will burn in 2 minutes. How long did it take for all 10 sparkles to burn down.
Okay, so this way, or in this question, I understood that we have 10 sparkles and we are going not to light them all together. We are going to light one by one when the first one remaining, or the first one is 1 over 10 of it. So, of course, when 9 over 10 of the sparkle will burn down, I'm going to light the other one. And the rest of it will be burned in this time. So let's draw some ideas. I have sparkles here. Sorry for the bad drawing. And so on till 10.
First, we gotta find the 1/10 of 2 minutes.
Okay, not 1/10. Look, we are going to lose 9 over 10 of the sparkle. And we're going to be left with 1 over 10. So the real question is, I don't care about the 1 over 10 of the sparkle because it will be burning when I light the next one. Okay, got the idea?
Yes.
So 9 over 10 of the 2 minutes is equal to what?
1 minute and 45 or 50.
Okay, keep it as a fraction. Keep it like this, and then we are going to calculate it in order to find the number of seconds if we have seconds. Okay?
Okay.
So 9 over 5 minutes, and then we are going to light the other one, 9 over 5. We are going to light the other one, 9 over 5, until we reach number 10. How long it will take?
We gotta add them.
Yes, you can add them or simply multiply them directly.
Yeah.
But by which number?
By 10.
No. No,
2.
this is the trick.
Ready?
They made a trick to let you fill in it. So look at it carefully. We have 9 over 10 of each one. So if you multiply by 10, the last one will be in this level. Okay? We need everything to burn down. If you multiply it by 10, you will get the last candle or sparkler to be on this level. No, I want it to burn down. That's why they said at the end, burn down. So completely burning down. How much does it take for it to completely burn down? Nine over 5 minutes.
Excuse me, Mr. Why 5?
Okay, because 9 over 10 multiplied by 2 minutes, we found that 9 over 10 of 2 minutes. And simply you can simplify because 2 up and 2 times 5 down.
Yeah, so 10 divided by 10. Okay.
Okay, so if I multiply by 9, or let me do it like you said, by 10, I'm going to get, we can simplify here before, so 10 over 5 is 2, 2 times 9 is 18 minutes. So you will directly circle choice C, right?
Yeah, but it's gonna be a little more.
Yes, it must be more because we are left with this part. We have 1 over 10 of it. We need also this part to be down. Okay, so simply you can do two methods. You can multiply it by 10, 18, and then add this part. Of course, you know we have 1 over 10 left, so 1 over 10 of the 2 minutes, you're going to calculate that. It will be 0.2 minutes, which is 12 seconds. Or you can start with 9 over 5 multiplied by 9 and then add 2 minutes. It's up to
Yeah, then
you.
add the last one. Yeah.
Okay, it's up to you. Which one is easier for you? Do it. You will get also the final answer. We have 0.2 minutes more, which is equal. Of course, you will have to multiply it with 60.
It's gonna be equal to 12 seconds.
Yes,
So B.
yes. Okay, so this is the trick. They made that for almost all the students answered with C because everyone look at it directly. I'm going to multiply 9 over 5 with 10 and I'm done. But we have missing part here.
Mister, how do you know there's a missing part?
Because it's clear in the question they told us when they are done with 9 over 10 of it or when they are left with 1 over 10 of it, they will like the next one, the next one. So we
Oh yeah.
calculated this thing 9 over 5 from the 2 minutes given. We know that it must take 2 minutes to take it all down. Okay?
Yes.
So if, in other words, if they told us that they will light each candle when everything is down in the first one, so simply it's going to take 2 minutes. I'm going to multiply with 10, which is 20 minutes. But there's a different technique here. Okay?
Yes.
It's clear now?
Yes.
Okay. Can you start reading this one?
Faisal walks up 8 steps, going up either 1 or 2 steps at a time. There is a hole on the 6th step, so he cannot use this step. In how many different ways can Faisal reach the top step?
Okay, so we have stairs of 8 steps. We are going up. Faisal is going up. And of course, he can go one by one or he can skip. You know, he can do it too.
Yeah.
There's a hole on the 6th step, so he can't use this step in how many different ways they want us to calculate the number of ways he can do to read the top step. So we're going to find different cases, case when he is using 2 steps, case when he is using 1 step. Of course, I'm going to teach you a small trick. So first of all, in all these kind of questions, draw to make it clear. So if this one is 1, 2, 3, 4, 5, I'm going to draw them all because we are going to use them all. 6 and 7, 8. Now the smallest trick here is, of course, he will never start with on 1. He will start from the ground, from 0. Okay?
Okay.
So if 6 got a hole, so of course when he is on 5, he will skip 6 and go directly to 7.
So that's one way.
This one is fixed. I can never play with it because 6 got a hole. He can pass through 6. So he will jump. He will do 2 steps. Now from 7 till 8, how many steps?
From what?
And it will never change, right?
Yeah. Cannot go to.
Okay, so also on 4, can he jump to 7 directly?
No.
Because we have two steps to avoid, so he's doing 3 steps. Of course he can do that.
He cannot go from 6 to 8 as well. So.
Yes, because 6 got a hole. So this one is fixed, and we are going to play on these stairs. So from 0 to 5, we are going to find any order, any sequence, to find the number of them, to count them and choose the right answer. So of course, in this case, I like using numbers. You can arrange them using numbers. So if we climb one step, I'm going to say 1, 2, 3, 4, 5, right? These numbers stand for climbing from 0 till 1, from 1 till 2, from 2 till 3, from 3 till 4, from 4 till 5. I'm not going to continue because it's fixed always that from 5 till 7 and from 7 till 8. Okay, clear for you? Michelle, if you want, you can find another partition.
Mister, can you hear me?
Yes.
Oh. Mister, can you repeat what you said? Okay, there here.
Okay, I said the following. We have these stairs. So 8 stairs and the number 6 got a hole. So of course I'm going to skip it from 5 till 7 directly. And when I'm at 7, of course, in order to reach 8, I'm going to do one step. So these are fixed. These steps are fixed and this will change in the black color, okay?
Yeah.
Usually I'm going to start from the ground till I step forward on the first one. So from 0 till 1, from 1 till 2, from 2 till 3, from 3 till 4, from 4 till 5. This one is a case. I can do it. Also, I can skip. I can skip stairs by doing 2, 2, for example.
Yeah.
Okay? So, for example, let me skip 4. I can go from 3 till 5 directly, right?
1 to 3 as well. 2 to 4.
Yes, 1 till 3, I can skip 2 also. So let me do it like you said. So I'm going to write 1, you skip 2, so 3.
And you skip 4, you go 5.
Yes, I can do that. You skip 2 numbers. So I have these partitions. I'm testing. You can never get the right answer directly. You're going to test all, you have to find all the ways, and then you're going to choose the right number. The reason why I wrote numbers because you can start by numbers without looking to this drawing. Okay, so
Yeah.
you're going to skip at least 1 each time. So here 1, 3, 5, you skip 2 numbers. Let us skip another 2 numbers, for example. So if I skipped 1, can you do it?
If you skip 1, go 2, then 4.
Okay, so I'm going to deal with 2.
4, then 5.
Okay, so you skipped 2 numbers also.
Yes.
But it's clear for me and you that we can do it more. We skip 2 numbers in 2 different cases. So once we skip 2 and 4, once we skip 1 and 3. So of course, we don't have 2 numbers to skip anymore. Now let's skip 1 number. Let's climb 1 by 1. And once we will skip 2 stairs.
Okay.
So, for example, 1, I can do it 1 here, I can skip 1 and climb 1 by
2,
1.
3, 4, 5.
So, of course, 2, 3, 4, 5. Now, can you skip 2?
Yeah. 1,
So,
3, 4, 5.
yes, and so on. Continue.
Yeah, I'm doing it right now.
We skipped 1, we skipped 2, now we're going to skip which number?
3.
Yes, so 1, 2, 4, 5. Also, we're going to skip 4.
1, 2, 5. Yeah.
3, 5, right. Now, the real question, can you skip 5?
No, you cannot.
Okay, because if I
So
skip
there's 9
5,
ways.
I'm going to jump from 4 till 7. 1, 2, 3, 4, 5, 6, 7 ways. Till now, we found 7 ways.
It's 9 ways.
No, it's not 9 ways.
Wait, let me check. 1, 3, 3, 4, 3, 5. Oh yeah, I reached 1. It's gonna be 8.
Yes, double check here the 2 steps. So I skip 2 numbers. Can I do it more?
No.
How?
You can only skip 2 numbers twice.
Yes, but look, I can also skip 1 and 4
Yeah.
because I can do it from 0 to 2 directly, and then 1 unit here, I can do it directly, and then I can go till 5. So I have also 2, 3, and 5. This is the
Yeah.
final case. Now let's count them.
8
For me, I
ways.
don't see any more. So directly we're going to choose 8. So if they told us that there's no hole here in 6, of course, we are going to deal with a lot of numbers. They will never do it because we don't have enough time. So this hole gave us a condition, first of all, to fix 5 at the end. Always, we're going to deal with 5. Also, we are going directly from 5 till 7, 7 till 8, 1 unit. So it's fixed here. We are changing only here. That's why we can do it one by one.
Yes.
Okay, now let's continue. This one, yes, it's nice. Can you read, please?
Numbers from 1 to 6 are placed in the small circles at the intersections of 3 rings. The sum of the numbers on each ring are the same. The positions of number 6, the position of number 6 is shown. What number is placed on the small circle with a question mark?
Okay, so as you know, from 1 till 6, all these circles have the number from 1 till 6. The sum on the same circle is equal to the sum of the other circle and the third circle. Okay, so of course, maybe 1, 2, 3, we don't know. We need to find algorithm to relate them. But whenever you are dealing with this kind of questions, directly write down the things you have. So I know that these circles, when they are summed on the same circle, of course, it's equal to the sum on the other circle, etc. So give them names, unknowns. Usually when I'm dealing with a lot of unknowns, I like using A, B, C, D, E. So if I call this one A, this one B, this one C, this one D, this one E, this one no need for naming it because we got a value here.
Yes.
Okay, what equations can I write with respect to these 5 variables and 6, of course?
First, we determine where is 2 and 4 because they add up to 6.
Okay, nice idea. So you are saying that 2 and 4 can't be on the same circle?
Yeah.
Okay, but in fact, I'm not going to find specifically each number. I'm going to find B only.
Okay.
Okay, so we're going to find equations, for example, for this condition, the sums of the numbers, etc. So, for example, look at this circle. A plus B plus D plus 6 is equal to the sum of the next circle. Equal, look at the other circle, of course. What do we have on this circle? I can see it clear. We have only C, B, E, 6. And in the third circle, of course, we have A, E, D, and C. Okay, and we know that these equations are equal because each one stands for the sum of numbers in the circle. So the first thing I'm going to tell you in mathematics, we can never find the resolution for A, B, C, D, E because we have 5 unknowns and we got only 3 equations, and these 3 equations are related to each other, so we can't find a solution for this. But we are going to try randomly for finding B. It's not randomly because we are going to work according to specific equation. So first of all, if you related these two equations, A plus B plus D plus 6 equals to C plus B plus E plus 6. Of course, I can subtract 6 from both sides, right?
Yeah.
Look at the common terms also. I got B
B.
and B. Yes, so simply subtract also B.
Now we're
So
left with A, C, D, E.
A plus D equals to C plus E.
Plus E.
Okay, and if I want to relate, for example, this equation, the first one with the last one, we are going to have what?
What was it?
If we related these two equations, for example, we got E and E common. We got C and C common, so B plus 6 is equal, let us write directly the result.
B plus 6 equal to A
Yes,
plus D.
great. Also, remember that A plus D is equal to what?
C plus E.
So we can find another one for B in terms of C plus E. Now you can do a lot of steps, but you will never reach more than this result. Okay, so the thing is the most thing you're going to reach, you will never reach a higher result. So now at least we can try from these choices directly in these equations. So it will be much easier for us. We got 1, 2, 3, 4, 5. So all the numbers from 1 till 6. Of course, we took 6, so we have 1 till 5, and we're going to test each one. The B, the question mark. So of course, we're going to choose one of them. But remember, these numbers will be less than 6 or less than or equal to 5 or 6 less than 6. So of course, for example, A is 5, D is 4. So it's equal to 9. B will be equal to 3. But if A is 5 and D is 4, so C and E will never take these two values. They will take these two values. They are equal, but 3 plus 2 is equal to 5. 5 is not equal to 9. So it's not my case. Usually in this case, because we are adding the higher one, start with the smallest choice. Okay, so the smallest number plus the biggest number equal to the sum of two numbers, any two numbers. Let's
Okay.
start with 1.
1 plus
So,
6 equal to 3 plus 4.
okay, no need for finding it directly, but yes, you
Because
are
7
saying that 1 and plus 6 equals to 7, equal, you gave 3 and 4, so
yeah, equals
7.
7.
Okay, you are left now with 2 and 5.
Hmm?
You, you are
So
left
C is
with 2 and
probably
5. 2 or 5, E is 2 or 5. 1 plus 6 is equal to 7. 7 is equal to 2 plus 5, which is 7. So yes, we are right.
yeah.
7 equals 7 in both equations. So directly we're going to stick on A. If you tried any other choice, you will get wrong results. So of course, stick on it directly. Okay, as you can see here, B is 1 and this one is 6. So A plus D, we know that it's maybe 3, maybe 4, maybe
Yeah.
2 or 5, but at least we got a small idea. We can never find them exactly, but we got idea and we found B because B is the intersection of these three circles. Okay,
Okay.
now let's continue. This one, this one is nice. This one will take you back when you were in grade 5, 6.
Should I read it?
Yes, please.
2021 has a remainder of 5 when divided by 6, by 7, by 8, by 9. How many positive integers less than 2021 have this property?
Okay, first of all, let me give you a small revision about positive integers. Positive integers, I'm talking about 1, 2, 3, etc. So the whole numbers, and of course they are positive after the 0 in the axis. So now when you have this kind of problems, it's not divisible by 6. When divided by 6, the remainder will be equal to 5. The same thing for 7, 8, 9. So, no need to understand the way you're going to solve. Directly, you're going to find the LCM for these numbers. Directly, without thinking. the LCM of these numbers 6, 7, 8, and 9. Of course, we are going to get close to the final answer, but we are not getting the final answer. Usually, when we have to find the LCM, we are going to prime factorize each number. So 6 is 2 times 3, 7 is 7, of course. 8 is 2 power 3. And 9 is what?
Uh, 3 power 3.
Power 3 power 3 equal to 27 on the
3
calculator.
power 2.
Yes.
Power 6 3.
Okay, don't worry. So, first of all, you're going to take the common. So now I got here 2 and here 2. So I need the 2 power 3 with the highest degree to be left. And of course, the same thing for 3 power 2 and 3. So I'm going to multiply with 3 power 2. And then I'm going to multiply with 7 because 7, there's nothing common here to take the highest degree. So it's 7 clearly. Now, directly we are dealing with 8. 2 power 3 is 8. 3 power 2 is 9. And 7. So we skip the 6 because it's common. And if you multiply them, the answer will be 7 times 8, which is 56, times 9, which is like the 10. 160 minus 56, so it's 504. Okay, now the LCM of these numbers is 504. Now simply I'm going to write it. I'm going to multiply it by 2, 3, 4 till I reach the 2021. Okay, so just remember this number is divisible by 9876. So of course it's not my case. I'm going to add the 5. So I'm going to make sure that the remainder will be always 5, will never change. Okay, now if I multiply it with 2, I'm going to get 1008. If I multiply by 3, 3 times 4 is 12. And 15. And if we multiply by 4, it's 16. 4 times 4. And 4 times 5, 2016. And now simply I'm going to start adding 5 to make sure that the remainder after the division will be equal to 5. So if I added 5, I'm going to be left here with 509. Here I'm going to be left with 1013, and down I'm going to get 15, 17, down 2021, like my case. But remember, less
than
than. So this case, we
not.
don't need it. So
Oh,
for
the
sure
next one.
now, I got 3 different solutions, so I can take this case
None
out.
out. 1 and 2.
This one. Okay, so it's a 3 or 4. Do you have more?
Don't think so.
I think we have one more. Usually, before starting with calculating the LCM, it's clear for me that I got 5. The remainder will be 5. So if you divide it, for example, 5 with 6, the quotient will be equal to 0, but the remainder will be equal to 5. The same applies for 7, 8, 9, right?
Yeah.
So 5 divided by 9 is 0 with a remainder
So there's
great
5.
equals to 5. So if I added 5 also the number, I'm going to get 4 choices. When I divide them by 6 or 7, 8, 9, I'm going to get the remainder 5. Clear?
Yeah, so it's 4.
Okay, usually others think thinks by this using the same technique. So I got 0, for example, and I added 5 to it. Because when we move from 0 to 504, then we are going to add 504. The same applies here. And you can start your question by this, because 5, the remainder, and it's smaller than the divisor, so of course it's a number. Okay,
Okay.
I know it's a bit hard, but usually when you solve one of them, you're going to have the way directly to solve this kind of questions. Okay, this one I found it easy because I didn't ask you on which class, 9 or 10?
9.
9. Okay, so you took everything concerning this. You know how to solve this, but you need to focus on it.
Okay.
So the figure shows a semicircle with center O. Two of the angles are given. So I got this angle 32 and this angle 67. What is the size and degrees of the angle alpha? Or in other words, the measure of alpha. Now, what is the first thing you will start with? We got a lot of given here.
Mm-hmm.
What do you see? For example, let me just give you names of a point so we will agree on. I'm going to name this point A, this point B, this point C, and this point D. Okay. First of all, angle facing diameter is equal to how much?
Angle what?
Facing a diameter.
Mister, I didn't took this yet. I'm gonna take it next week. We start diameters and test today. So
Okay, usually you got a small idea about this, so
yeah,
directly
we have some.
I'm going to tell you that any angle that starts from the circle itself and faces the diameter, the whole diameter is equal to 100, equals 90, sorry. So I know this angle BAC is equal to 90 because it's facing a diameter, okay?
Okay.
And when this angle is equal to 90, of course you can find this angle, right?
Yeah, it's gonna be minus 90. 180 minus 30.
Look, you have a right triangle. We are dealing with ACB. Now I'm talking about
Oh
the
yeah.
ACB. So,
180 minus 90 minus 67.
yes, right.
So wait, let me check. 180 minus 90 minus 60, 23.
Yes. So this angle is equal to 23. I'm going to write it up because I don't want it to be busy here. Now, another ideas. Do you have something clear for you?
What do you mean?
Something you took before when you were a kid, not now.
Something I took before?
The first thing after taking the center of a circle, we said which side is equal always to the other side.
Side is equal to the other side. The radius.
Yes, of course. So where do you have radiuses here?
We have A to O, that's a radius. D
Eh,
to O, that's a radius.
do you have another radius?
D to O and C
Yes.
to O.
Yes, great. So I got here
Equal.
4 radiuses drawn. So of course they are equal in their length.
Yeah.
Now, if you want to relate them, usually when we have triangle and we have two equal sides, the triangle is called what?
Uh, what did you say?
With two equal sides. Triangle with two equal sides.
Yeah, isosceles.
Yes, isosceles triangle. And a property for isosceles triangles is concerning the angles.
Yeah, it has how much?
It has two equal angles.
Yeah.
So for example, ABO, I know that this side AB is called the base, and AOOB are the legs. They are equal. So these angles are equal. So we know that this one is equal to 67, right?
Yes.
Because AOB is an isosceles triangle. Do it for me also in another case.
Another case is from D to O and A to O.
Yes, DOA, this triangle.
Yeah.
Which angle? ODA. It's clear, 32. It's equal to which angle?
Is equal to the A.
Yes, but be specific. So you're going to name, for example, from O to A and then A to C or D.
What's this?
Yes, tell me from the beginning. So it's equal to OA, which angle? AC or AD? OAC or OAD?
AOD. AOD.
OAD, you mean, right?
Yeah. Oh, A.
Okay,
Yeah.
so this one is equal to 32.
32. Yeah, but we gotta minus it. The part and find A.
Minus alpha, you're going to find this. Minus this, you're going to find alpha. Of course, we're going to minus this. This, how much is it? We know a
Uh,
lot of it. We can do it.
yeah, because we can find the whole. Oh yeah, 19.
CAB is 90. And
Yeah,
OAB is what?
67.
Yes, so of course, if we subtracted 67 from 90, we're going to get also 23. Which one?
The bigger one.
Here, this one.
Yeah, the bigger one. We're gonna
23.
32 minus 23.
Yes, it's equal to what?
It's equal to alpha.
Okay. Calculate it for me directly.
It'll be 9.
Yes. And 9 is
So
equal to alpha.
8. 15.
Okay, great. So how it looks like a hard one, but we solved that simply. Okay?
Yeah.
Thank you so much, and please join us tomorrow. We will continue from 15.
Okay, بس. Bye, have a nice day.
Bye bye.